So as we define the vector function R takes on values from its domain to, for example, the space. If it has two components, it maps T into the plane. So make sure you know the vector function mapping the T values to R squared, to the plane, or to the space. Now, suppose we have the following example. The example says, well, consider the following curve, R of T, which is defined as square root of T, and 2 minus T. Sketch the position of R of 1. The position of R of 1. So first of all, we have a vector function. Or vector valued function. The function takes on values and it gives you vectors. The output value are vectors. Square root of T has domain 0 to positive infinity, and 2 minus T is continuous everywhere. The domain is going to be R. Now, R of 1, just need to substitute square root of 1 and 2 minus 1. What is the vector here? You're going to have 1 and 1. This is the vector that you're dealing with. So if you want to take a look at the graph of this curve, the x value is square root of T and the y value is 2 minus T. You have different methods graphing this curve. What you can do, you can just plug in different values for T and you have a bunch of dots connecting them together, or you can find a relation between X and Y. What's the value of T? What's the value of X? And what is the value of Y? X position, Y position, or F and G. It doesn't matter which one you're using. And R. So if T is equal to 0, what is my X? What is my Y? My X becomes square root of 0, which is 0, and my Y becomes 2 minus 0, which is 2. So the vector is 0 and 2. Okay, let us begin. At time 0 second, the position of your particle is here. Just plug in some points, some values. My X and my Y. At 0, my vector is located at 0 and 2. Well, what if I plug in 1? Then my X, as you can see, is 1. My Y is 1, so the vector is 1 and 1. At the time equals to 1, 1 hour, 1 second, any unit that you can work on, you have 1 and 1. So you're going to be right here, 1 and 1. Okay, what if I plug in, for example, 2? What do I get? My X is square root of 2, and my Y is equal to 2 minus 2, which is 0. So the vector is square root of 2 and 0. Square root of 2 and 0. There we go. So some part of this curve behaves like this. This is my R of T, some part of it, between time 0 to time 2. This is the behavior. Now, and I ask you to sketch the position of R of 1. Remember now, at T equals to 1, the position is this vector, 1 and 1. So you're going to connect the origin to 1 and 1. And this is vector R1, the position vector 1 and 1.